Hi everybody, we are now still in problem set 1.1 and we are now in question 13 and this question and the next one they refer to the drawing in the top of page 9. You see this clock. Okay, so let me copy the clock. We'll make it bigger. Let's make it in the radius of, let's say, 10 centimeters. Okay, okay, so, and we'll put it in the middle of the page. So about here. And we'll make a circle. Okay. So this is our circle. And let's make it, the circumference, we'll go over it in black so we can see it better. Okay, this is the middle. Here we make the coordinates, the axis. So this would be the x-axis. This would be the y-axis. X. And the angles each time are, we have, for example, in the first quadrant, we have, okay, we start with the hour 12 and we go, like in the clock, we have 12 and then 1, 2, and 3. So in the same way, we have, I don't have numbers in my watch, but you understand that this is the first quadrant. So here we have 1 and 2 and 3. Okay, so this is the hour 3, this is the hour 12 or 0, and each here we have 90 degrees. Okay, this is 90 degrees, and we divide it into 3 hours, 1, 2, and 3. So 90 divided by 3, it's 30 degrees. Okay, so 30 degrees, let's make it the exact angle. Okay, so it should be here and here. Okay, and this is the hour 1, this is the hour 2, this is the hour 3, okay, and so on. And then each one of them is a vector, okay? This is a vector, this is a vector from the origin, from 0, 0. This is a vector, this is a vector, and so on. And okay, maybe we'll draw them all and not be lazy. Okay, so just give me 1 second. 60 and 120 and 150. Okay. Okay. Thinking back, we could have done half of them, okay, and putting the ruler all across the circle, and then making only half of the measurements. But anyhow, this is how I've done it already, so it's less accurate and it took more time, but never mind. Okay, so each one of them is a vector from the center, okay, and they are in 30, in each place there is 30 degrees. Okay, this is 30 degrees, and each one is 30 degrees. Okay, so now let's see the question. The question is what is the sum of the 12 vectors that go from the center to the hours, to all the hours? Okay, if we go around and around and around and around, okay, we take this vector and we add this vector and this vector and this vector and this vector. For example, if we added this one, we walked along it, came to the end, and then take this one and put it here, okay, and went along this one, and then take this one and from here went here. Where do we end up? And the answer is they all cancel each other, okay, because each one has someone that is the negative of it. If we have this one, okay, upwards, we have another one which is the negative, which is downwards, okay, it's the opposite. So that these two, this one and this one, cancel each other. The right and left cancel each other. The 1 and the 7 cancel each other. The 2 and the 8 cancel each other, and so on. So the answer to A the sum V equals the zero vector. Okay? We make a small arrow to show that it's the zero vector, not just zero. Okay? Because we didn't move at all. Zero means we don't have anything. Zero vector means we didn't move. Okay? From this place, from the origin. Okay, now B. B, if the 2 vector, okay, this one is removed. I'm sorry, you can't see in the camera. This one. If this one is removed, okay, we take it out of the, sorry, of the clock. Why do the other ones add to 8? Okay, this is 8. So again, it's like the question in A. This is because the 2 now doesn't cancel the 8. So all the other ones cancel each other. The one upwards cancels this one. The one downwards. The one to the right cancels the one to the left. The one to 11 cancels the one to the 5. Oh, okay, each one of them cancel each other except 8, which doesn't have a partner. It doesn't have the negative of it because we said that 2 is no longer in the game. 2 is removed. So 8 remains not balanced. So it takes all the other ones cancel each other. So we stay in 0 in the origin, and 8, the last one, 8, takes us here. Okay? So this is the only active one because it doesn't have a partner to cancel it. So so let's write it down. We'll try to write it down. Because all the other vectors cancel out, cancel each other out, except uh, 8. Okay, I'm writing 8 like this. It's like, it's not a good way of writing, it's just the vector of 8. Let's write it more clearly. Except the vector of the hour 8. Okay, so this is B. Now let's see what is the question in C. C, they ask us what are the components of that 2 vector. Again, this 2 vector, if we call it V, what is V made of in terms of trigonometric functions? So it's cosine theta and sine theta. Okay, if this angle is called theta, I'm sorry, it's with th. If this angle is called theta, what is the cosine of theta? What is the sine of theta? And imagine this is the length of each line is 1. Okay, so from here to here, it's for us it's 1. So we are looking for what is a cosine with this angle, cosine 30 degrees times 1, and sine, sorry, there's a plane. 1 second, it will pass. Okay, so sine 30 degrees, theta in our case, the angle is 30 degrees because we are looking at this vector and we start measuring from 0. Remember, if we calculate degrees, it's always from the x-axis, the positive line here. Okay, it's going like this. So this is the 2 vector is 30 degrees from the beginning, from the start. Okay, so how much is cosine of 30 degrees? Sine 30 degrees, I think it's half, but let's check it out in the calculator. I don't remember by heart. I think it's half sine of 30 degrees. We'll go into mode. Sorry, shift and setup. Well, normally we have it in radians. Okay, shift and setup gives. I don't know if you have the same calculator in Casio. Shift and setup puts us in this model FX991ES. It gives us the setup, and here I'll choose degrees. Okay, it's important because the an angle can be measured in all sorts of different ways. It can be in radians and in all sorts of ways. We are choosing degrees. Okay, so I'm choosing 3 degrees. And now if I'm writing 30, I'm sorry, sine 30 and close the parentheses, although we don't have to, equals half. Okay, so the sine, which is, remember, sine is how much is this. I'm just closing the window because there are planes all the time. Okay, sorry, I hope they are peaceful, not going to do some harm. Sine is, if you don't remember, it's the part, this part of the triangle. Okay, if this is the triangle, let me draw it. We'll draw it in red, for example. I'm just making it thicker so you see that it's red. Okay, so sine, I'll write it in here. Sine of some angle equals, I'm just looking to see what's the word for this part of the triangle. 1 second. I think it's side, but I don't want to make a mistake. Yes, it's side. So this side of the triangle, okay, if we have the triangle from the origin up to here, and then this vector we said it's 1. Okay, I'm just writing this length is 1, the same way as this is 1, this is the length is 1, the length is 1, the length is 1 of each one. Okay, so this is the unit circle. So this is 1. This side of the circle is, or let me say it in another way, sine theta, if this is theta, theta equals 30 in our case. This is the angle. The angle theta equals 30. The angle theta equals 30 in our case. So sine theta is the opposite, the side opposite of the angle divided by the rest of the triangle. Okay, let me see how it's called in English. 1 second. Okay, the hypotenuse. Okay, so this is the hypotenuse in a right triangle. This is a right triangle. Okay, this is 90 degrees. The hypotenuse is this side. Okay, here the hypotenuse equals 1. In this specific case, it doesn't have to be 1 every time. In this specific case, we are talking about this vector, this line is in, the size of it is 1. We don't know if it's 1 meter or 1 yard or 1 whatever, but it's 1. For us, it's 1 from here to here. This is the hypotenuse. This side opposite of the angle theta, we just call the angle theta, but we can call it in another name. But opposite of the angle, we just need some name, so we decided it will be theta. Okay, so opposite of the angle, there is this side, and sine is the relation between this side, the ratio between this side and the hypotenuse. Okay, so it's opposite side divided by the hypotenuse. Okay, so if we want to know how much, we know how much is the hypotenuse, we know how much is the sine theta. Okay, we said the sine in our case, it's a sine of 30 degrees. So sine of 30 degrees, we already calculated, it's 1/2. So this is half in our case. This is 1. And the opposite, if we want to know how much it is, we put into the equation all the numbers that we do know. Here we put half. Here we, instead of all this, we put half. Instead of all this, we put 1. And then we have half equals opposite divided by 1. So opposite is equal to half. Okay, so here I'm writing half. This is half. Okay, now let's see in another color, let's make it blue, how much is this length. Okay, from the origin, I'm sorry you can't see, Okay, how much is this length? From the origin to the this side of the triangle, okay, to this, up to here. So how much is this? This is measured by the cosine, okay? The cosine function is very similar to the sine function, but it's, instead of here having the opposite side, it has the side next to the to the um, to the angle, okay? So the side that is close to the angle, that is right next to the angle, okay, this side, not the opposite side, which is far away from the angle, but the side that is close to the angle. So we have cosine, let's write it here, we have a little room here, cosine theta sorry, I didn't make a parenthesis. It's very important in a function. It always has something which is the input. Here we put inside of cosine, we let it have theta, okay? So we are looking for what is the cosine of theta, and of is like we put it in parentheses. Okay, so you'll see in a minute what I mean. Cosine of theta, in our case, it's cosine of 30 degrees. I think it's something with the root of 3, but I don't remember exactly. We will do it in the computer. So cosine, it's this button of 30 degrees. We are already in degrees, equals the root of 3 divided by 2. Okay? So if cosine theta is, in our case, I'm writing it here, okay? Cosine of 30 degrees equals the root of 3 divided by 2. Okay? So cosine of theta in general is the side close to the angle divided by the hypotenuse. Hypotenuse okay, the side that is close is the one that we are looking for. It's this. Let me make it in blue. Okay, the blue line is the one that we are looking for. This is what I call the close side. This side of the triangle, which is close to the angle. So cosine of the angle is the close side of the triangle, close to the angle, divided by the hypotenuse. In our case, the hypotenuse is 1. So it's just, if something is divided by 1, it's just this something, okay? For example, 5 divided by 1 is just 5. So the closed side, whichever its size may be, divided by, in our case, the hypotenuse is 1, okay? So we can just say here, in our case, in our specific case, because the hypotenuse is 1, it's just the closed side. So cosine of 30 degrees, which is the root of 3 divided by 2, equals the closed side. So this equals root of 3 divided by 2. Okay, so now we can answer what they wanted. So they asked us what are the components of the vector v of cosine theta and sine theta. So the measurements, I'll write it here because I don't have another place in the page. I'll write it here. So C V, the vector, equals okay, I'll start a new page. I'm beginning to be cheap, so we'll just make it in another page. So 13 continued. And we have, we are talking about 13C. And we said, I'm reminding you that this, let's say if this was 10 centimeters, make it in the correct colors. This was blue, and this was red. And this was black. And this was 1. Okay, the hypotenuse was 1. And we said already that this side, the opposite side, the far away side, was 1/2. And the side that is close to the angle, here is the angle, was the root of 3 divided by 2. Okay, so they ask us what are the, if this was a vector, okay, this is the vector of the hour 2, okay, remember this was the origin, or 0, 0, this was a vector, and here was the hour 2. Okay, I don't want to write 2 because I don't want to confuse you, but this was the hour 2. And what are the components of the vector? So the vector is how much, the first component is how much we go to the right. The second component is how much we go upwards. So we just write it down. Okay, it's just like we had two vectors here. Okay, if this was a vector and this was a vector, and we add both of them together to have this vector. Okay, so the vector, let's call it V, equals the first component is the x component, so it's the horizontal component. It's root of 3 divided by 2. And the second component is the y-axis component, how much we went upwards. Okay, this is the x, this is the y. So x and y. So this is half. Okay, and this is the answer. Okay, vector v equals 1, I'm sorry, root of 3 divided by 2 as the first component, and the second component of v is 1/2. Okay, so thank you and goodbye.